Good afternoon, folks. Today we're going to be studying what is the turbine for an oscillating water column as shown here. And let's do very quickly the animation of this so people will understand how this behave. And and here we go. So this is basically what we're going to be designing today is how we're going to put together this kind of weird looking turbine. All right, and so before we go, I will explain why it's so important to have this kind of turbine on our oscillating water column for energy extraction. This is a simulation for an oscillating water column energy extraction from the ocean wave. As the wave rises, the level of water in the inner chamber rises as well, so it pressurizes the air that the only escape is through this pipe to the atmosphere. Then, as the water level drop, air from the outside go into the pipe backward direction, meaning that there's a turbine here that needs to turn only in one direction independently of whether the air is going out or going in. That requires special turbine, and this turbine was designed originally by Mr. Wells and is based on a NACA 0015 blade design. So that now we understand how the oscillating water column behave, the idea is for us to design this turbine that is right here. All right, and for with that in mind, we can see a little bit more of detail as shown here, that independently of whether the air will go out or will go in this direction, the turbine needs to turn only in one direction. As you can see, this is kind of a profile of the wind turbine, which is basically a NACA 0015 type of design. Looking into sort of like a small scale turbine, I went through some papers and I found this kind of interesting of about this design. This is kind of weird for me how this turbine looks like, because it has very short span on the wing and a huge rotor, which is kind of it's the first time I see this type of turbine, and it's kind of interesting the way it is. So they use this design in a wind tunnel. So I want to see how close I can, configure my turbine and do a simulation in SolidWorks in CFD. So these basically some of the parameters that they use on the wind tunnel. So I will go through them as well. And as you can see, the inner radius for the rotor is about 100 millimeters, and the outer radius is about 155. And this is the section, is the cutoff for the BB right here, as shown here, which is basically a NACA 0015 type of blade. And here's more of the details. The core 74. This is important for my design, and the number of blades 7. That's basically it. No more to it. Let's see what else. I'm gonna be using Fusion 360. For Fusion 360, I'm gonna get this Airfoil sketch. So I download these into my Fusion and load it and did my design based on this application, which requires that you have previously downloaded your profile, which is right here. I download my profile from Airfoil Tools, and here is my NACA 0015. You can do a search for any other one. So this is basically what you have to have, and you need to copy this data. So I will show you all that, and so make life very easy. So at the end, you will end up with something like this. And that's basically my design, and for 3D printing of this blade. So if I go right here and do the simulation, the anime of that, so that's how it should behave. No matter whether air go this way or the air go into the other direction, the turbine needs to turn on the same direction all the time, which is kind of very, very interesting. So what we're gonna do now is start my design so you know how I did all this. All right, so let's stop here. Hello guys, so here we are back again, and so the first thing that you need to do is to download this Airfoil generator for whatever machine you have, and after you download it, you install it, and then you launch your Fusion 360, and it will not be there. It's kind of tricky how it, how you detect whether you have it or not, but I will show you that in a second. So the idea is ensure that you download it. All right, because that's what we're gonna need, and this is kind of a neat application for if you are into airfoil. All right, so let's say that you have that. The next part is you need to go, let's say, to your where is your NACA profile that you're looking for. Like for example, I'm looking for this 0015, and the data, you can. It's so easy to look for this air. You put air tools NACA 0015, and it will pop. This page will pop out. So very straightforward. The important thing is that here's the data. That's all what you need. Now there's a few tricks here and there that you want to apply to this data. The first thing is let's get that data out. So I'm copying that data. Only the data. Copy. Control copy. That's it. Now you have it. Go to your Excel spreadsheet, and let's say that you pop this information right there. You paste. The first thing that you notice, this is like a string of, it's not numbers. This is a strings. So you got to convert all that strings into numbers, So the best way to do that, Excel has all that application to do that. We need to convert this text file into numbers. So text to column, do that. Oh, sorry for that. Stop it 1 second. Let's pick the whole thing and now do text to column. And when you do that, it's pretty much start to show you something that is being separated properly. So you do next, and here, depending on whether you pick what you have to pick, like for example, what's your delimiter, I tend to put tab, comma, space, maybe others if there's a special character or something, but that's just more than enough because it already did the trick. So do next, just in case you want to be sure that everything looks good. Yeah, I don't see any problem. So finish, and there you have it. Now you have separated your data into 2 columns. That's perfect. That's perfect. That's what I want. Now, when you have your data separated, now this is sort of like the X and this is the Y. We want to save that data. Well, actually, before we do that, we want to be sure that this data is kind of close. So in fact, if I do, let's do very quickly, let's do this, and let's do perhaps this just to show. Well, that's not that good, but it then tend to have an idea how that would looks like. Looks perfect to me, but let's see. Let me direct this again and let me redo it again. But let's see if this is worth to mention. And yeah, that would do. So let's open this big. You see, these 2 points are not together. They're open. So that's not good. I want this to be as close like the others, but here is a problem. And the problem is the way that the data was shown for this. Like for example, 1 is almost 0, but then here. And then the other point is this one. 1 is almost 0, but it's not 0. So, it's not a big deal to go and change this to 0. And you have this as well, change it to 0. And when you do that, well, this one here. There we go. Now it's close, you see? Now it's perfect the way I want it. Looks like a drop, isn't it? Looks perfect. So with that said, now we save this. I already did this, but let's save as so what I'm doing, let's see, I want to save it here somewhere. Now, here's the important part. You want to save that as a CSV file. You see, I already have a NACA here. So let's save it again, like NACA 0015 rep 2, like a revision or something. Let's say, because it's important that you save it as a CSV file, not a Excel file, a CSV file, which is a comma delimited file. Excellent. Now you're ready. Now you go to your Fusion 360, and let's say that we want to start a new design. So we are right here, and when you start your new design, then you said, well, let's see. Let's check here, millimeter, that's perfect. And now let's work on the, I think I would work, I like that. So, and in the right plane. So the first thing that we need to do is, it's kind of weird. You don't see anything here, but if you try, for example, under create, there's the airfoil. It starts to show up. And this is what confused many people when they start to use airfoil for the first time. If I try to use it, the first thing that I tell you, select a construction line. You have to have a construction line, which is basically the core. So you need to have that construction line at the size of your core, which bring me back to my presentation in one point in time that I said it's very important that I have the core right here, which is set 74 millimeters. So I have to have that design. So let me go back to Fusion and let me install a line here. And that line, let's make it any length. And but that line has to be a construction line. That will do. So now let's pick the dimension of the line will be 74 right there. Now, what I don't like about this line is I want to put this line right at the middle of this line. I want to be right here on this on the center. So let me do something else here. So let me pick here and here, and that distance, let's say that distance will be 74 divided by 2 right there. So now my core line have a center, which is right here, and that center is important later on. So anyway, you already have it. The next step is to go here and now pick the line, the construction line that you have, and now you're okay, start to work. When you hit it here, then you go to your file, either this one or this one, it doesn't matter. Actually, let's use this one just for the sake of the argument. And when you do that, open right there. You see? No problem. It looks perfect to me. Perfect. That's it. And from there, you just finish your sketch and you can do, for example, your extrusion. Let's do a big extrusion here. About, I don't know, 200. I mean, 100. Let's do 100. It doesn't matter at this point what you do because you're going to cut this later on. But how about that, huh? Just few instructions and you have a beautiful NACA 0015 profile right there. Nothing more to it. So now let's work on the rotor for this wing profile, and let's see how this looks like. We're gonna do right from the top, and here's the important part. Here's where the center that I talked to you about it, to have everything right where you want it. So now the next part, let's do right in the top, and let's do somewhere here. I don't remember the diameter of that, so let's go here for 1 second. And the inner radius was about 100, meaning 200 on the diameter. So if I go back to Fusion, we need to make this guy 200. Now let's see, and there's the part, and so we need to move this guy. Actually, escape 1 second. We need to move this guy so it, it can barely touch the. There we go. I like to make it barely touch this corner right there. That I can certainly do better than that, but it doesn't matter at this point. That will do. And so the next step will be actually, let's do the extrusion of these guys. So now they start to looks more like the finished product. Let's say finish is okay, and let's go right there. It's right at the center. So what we want to do is get this extruded distance one side. Actually, it's gonna be two side. It's gonna be one. Let's 20. Let's see. I would say a little bit less than that, but that's look good to me. You can make it smaller, but that certainly 20 is okay. If I need to cut it off, I cut it off at a later time. So let's leave it at 20. Let's say it's not a cut, but a joint. Everything's joint, so let's say okay. That start to look better. Now, let's see what we got here. Let's do quickly there. Let's do, I don't know, 2 millimeters. Let's see how it looks like. Maybe 3 at the most. That looks better. That's fillet. Just say okay. Now it's getting better. So now the next step, let's get the axle right there. So let me get the axle will be about 15 millimeters. So let's say enter, and now let's go back here and do that one. We're gonna go all the way down. So that's okay. Good. Okay. There we go. We got that very nicely. Now, the other part that we need to ensure is the length of this. And it's kind of interesting, but if you go back to my PowerPoint and you check, you see how they end the blade, meaning that there was sort of a cut, it's kind of a cutoff. There's no straight, but kind of in a circle. And I need to do that at 155 from the center, meaning at 300. So, meaning 150, that would be 310 millimeters. So let's go back to Fusion, and let's pick this guy, and let's pick this guy, and let's pick this guy, and we're gonna have a circle which is about 310. All right, so that's 310. And let's do, and this is the funny part, so let's accept that, and let's do another circle which is larger than that one, that will cover the portion that you want to cut, which is this portion here. And it doesn't matter how big it is, as long as you cover this tip here. So that finished cache. And now when you look that from the top, the only thing that you need to do is pick this guy down, do an extraction, but a type of cut. It's not going to be a new body, but it's going to be a cut. And we're going to drop, where is it? Right here. And we're going to cut, and that's going to cut the external part, and that will do. So let's say okay. Yep, that's it. Now you have this kind of a circular end of the blade, which to me it still bothers me how short it is. This blade is so short. I mean, I don't know how this turbine really works. So that's kind of interesting, and with a big rotor. So I'm doing what I saw on that wind tunnel study. So, and that's basically looks like perfect to me. Um, Now, this is, I believe this is kind of a one body at this point. Let's see how many body I have here. Exactly one body. That might be a problem later on, but you will see that there's a way around. Kind of a tricky, but I don't care. Get the job done. So I need to um, do 7 of this guy. I already have one, so there's a little bit of a problem, but you can easily solve that problem if, for example, you want to do right now. Let's say that I want to create a pattern, a circular pattern. You can select the body, which is this one, but you will have a problem selecting the axis because everything's one body. So it's easy to solve that if you go right here and then unconstruct and you put an axis. Axis to there. And you say, okay, now you have identified yourself one axis that will allow to propagate this display. Now let's do that. Let's go back again to create and let's go to pattern and let's go circular, and now it's just the body. The body that's been picked is the whole thing together. That's what I said. That doesn't look good, but I don't mind. I don't care. Now select the axis that you want, which is that one, and then put the number of blade. It's already have the 7. It's not a miracle. It's just that I did this before and it kind of remember what I did. So I decided to, make a video out of it so people know, maybe they have maybe better trick than what I did. It's right there. So it's perfect. Pretty much this blade is done as when I hit OK. The only problem is that you have so many bodies that doesn't make any sense. And one thing that you could easily do to have one body, because that's basically what you want, is only one body. So that's easy. You just go right here and then select everything that you want. You see if I'm missing one. Yep, missing this guy. There we go. I got all of them. Just say OK. Did I got everything? Let's see. Yep, looks everything. Just say OK. New component, maybe. I don't care. And there we go. Body tree. Body tree is everything. Now it's only one body, which is what I want. That's it. And that one body can become eventually. You can make that a component from bodies, and that will do. You can do rotation or whatever you want. The only important thing here, anything left? Maybe I can do. Let's see. Let's see 3. That looks good. Let's say OK. Maybe the other side as well because air will go both ways. So let's do also a fillet. Let's see. Let's say a 5 to look. It looks better on a 5 actually. Let's say OK on 5 and let's redo this one, and so that we kind of edit that one to 5. Excellent. That's it. Now you have your kind of a weird. I would still bothers me this turbine how they looks like huge rotor, very small blade. But that's the kind of thing that you want to definitely test. This is weird to me. I'm gonna say this and do a study on SolidWorks for CFD, and let's see what is the behavior. Anything else here? I don't think so. Maybe you want to create if I go back to my arena, you can put But that's just nonsense. I mean, this is straightforward. You don't want to do, you don't want me to repeat all that together back again. So um, this is it. That's basically it. Have fun, folks. Bye.